Hello guys, welcome to another session of the recursion course. Here we are in a topic that is called printing all permutations. We are gonna try to print the permutations of a particular string using recursion. That's what our goal is gonna be. So what is the task? What is the problem? You have been given a string and you have to print all the permutations of it. Simple. Let's suppose we have an input string called ABC, the three character string. Your output should print all the possible permutations of the string ABC, like ABC, ACB, BAC, BCA, CAB, CBA. So basically, you're altering the positions of the characters. That's what we are doing. So what's your idea? You are iterating from first to last index. For every index I, suppose you're in index 1, you swap the ith character, you swap the first character with the first index. This is how you're going to fix the characters at the current index and you're going to recursively generate all the permutations beginning with the fixed characters. So your point should be, your approach should be that for every index I, you're going to swap the ith character with the first index. After which you are going to recursively follow the recursive calls. That's it what you're going to do. Let's have a look at the illustration. That's the idea that we talked about. In the illustration, what we're going to see is how we are gonna permutate, how we are gonna find out the permutations of ABC. You swap A with A. Then you recursively generate all the permutations beginning with A. So then you swap A with B. So first index with first index first swap. So it's common, it stays intact. Then you swap A with B and generate all the permutations beginning with B. Then you generate all the permutations beginning with C. So you are basically swapping the index I and the ith character with the first index. That's what you are gonna do in this algorithm. Here it's a very cool diagrammatic view of what I explained. So the index was A, B, C. The 0th index was A, first index is B, the second index is C. In the left side of this representation, you can see in case of B, what it's written, you have to swap A with A. So here A is swapped with A, here A is swapped with B, here A is swapped with C. What happens here is you are swapping B with B, so now AB is fixed. Here you are swapping B with C, so AC is fixed. Here again you are swapping A with A, so BA is fixed. Here A with C, so BC is fixed. Here you are swapping B with B, so CB is fixed and your CA is fixed. So this is a recursion tree of permutation of string ABC. So we have represented this theory using this tree structure. So the red ones are fixed and you are making alterations so on. I hope this is understood. So the red ones are the fixed characters and the black ones, they are permutative. So the time complexity of the code that which we are gonna write is n cross n factorial, where n is the length of the string and there are n factorial permutations and it will require big O of n time to print a permutation. The number of permutations possible are n factorial and it will take big O of n time to print a permutation. And the auxiliary space that we are going to do is obviously big O of n because again we are using recursion, it's a no-brainer. We are using a stack here, so big O of n is there. Now let's do one thing. Let's go to our VS Code and let's try to run it. So let's write the code together. Okay, let's go to the coding section. I'll just suggest you just pause it for a second and give it a try. If you can't, then come back and have a look. The people who have already written the code, you can come and check whether your code is right or not. Let's write a function, permute the string s, and let's put a path. Okay, this is done. Now, I have done something. Okay, here. The semicolon should be here. Then if not the string, the base condition, you're gonna print the path. Cool. Now let's write the else part. We are going to have a loop here for I in range, length of string, permute, put the index values here. Okay, now plus the index value should be put again the string, the index of the strings that we are going to work on. Then let's put path plus of I. Okay, done. Now the driver code. If name is double equal to your main, your S will be equal to A, B, C. Okay, and let's put the, this is not a capital S, the string S. Okay, and let's call the permute. Let's put it. Let me save it and let's run it. Here, you got all the permutations ABC, ACB, BAC, BCA, CAB, and CB. So I hope it was understandable to you. I hope you understood the project completely, understood the code completely, you understood the theory section, what are permutations, how to find it, the time complexity, the space complexity. I think it's all of it is clear to you. So with this, I would like to wrap up this session for today. Till then, keep coding, keep learning, and keep rocking.